In this video I'm going to be demonstrating my Arduino test bench for Apollo alarm devices. These devices on the test bench right now are only XP95 and Discovery. These smoke detectors are Discovery, call points XP95. The base sounders and just the beacons are also just XP95, so there's nothing special there. They are all wired to these Wago terminals, like in a star topology, so they're all going to this point. They're not wiring in and out, they're not looping in and out like you do on a normal system. But this is just for testing purposes, so it doesn't really matter. It all works regardless anyway. So the drive lines come out of the breadboard here. They go through this back box just basically to neaten it up as best I can. It comes through here, and it goes to these. Oh wait, no, it doesn't go to these. It goes to this first. So it goes to this card first. It goes through here, and it comes out. Then it goes to these, and then it distributes to all the devices. I could wire these in a normal topology, like loop in, loop out, but I had the pigtails on all the devices anyway, and I just thought for convenience, I just stuck them in the Wagos. It doesn't matter. I don't need the isolators to work in them. And yeah, that call point's just sitting there with the aid of gravity, so that's probably going to fall a few times throughout this video. And the screws there, let's just put that somewhere safe, like just stuff that in there and screw it in just so it doesn't get lost, because there's no captive ring on it anymore to stop it from coming out. Okay, so I'm going to demonstrate the first function of my program, which is the learn network function. What this learn network function does is it will scan from 0 to 127, and it will basically record what devices are responding. So it will just count and send out an interrogation packet to all the addresses, one after the other, and you'll see them appear in the list when I activate the command. So as you can see, the addresses are incrementing, and it'll get to 127 and it'll report back what it has found. So it says it's found 5 devices, and it's reporting back the addresses also. They're also in numerical order as well. So it's 1, 2, 3, 4, 5. It's because I've addressed these devices 1, 2, 3, 4, 5. But if I take this head off, this is address number 2, and I do this command again, just gotta let it do its thing. And there we go. So it has found 1, 3, 4, and 5. So that's the addresses it's found. I could also change the address on this device here, which is the sounder base beacon. So what address is this going to be? So that is 001, which is 1, 2, 4. That's address number 4. 8, 16, 32, 4 plus 32, 36. So that should be address number 36. So if I do learn network again, the found addresses should see device number 36. So there you go. So it's 1, 3, 5, and 36 as the devices found. So I'm going to flick that switch back up, pop the head back on, relearn network, and we will proceed to the next demonstration. So learn network again. May have just saw the LEDs pulse there. I'm now going to demonstrate active poll mode. What active poll mode does is it will scan through all the found addresses, so it will be asking for the data from all the devices that were found in the learn network part. So if I put active poll into the terminal and then enter that, we will get all of the analog values from the devices, and they'll update relatively quickly. As you can see, addresses 1 and 2 are different and they are changing constantly compared to addresses number 3, 4 and 5. Address number 3 is the call point. There is no analog, well, really an analog sensor to get data from, so it's only got 2 states. It's got the state with the glass in, and it's got a state with the glass broken. So if I take the glass out, this is basically simulating breaking the glass, you will see address number 3 go from 16, it'll drop down to 0, and then it'll settle at 64. It goes to 0 because when you activate a XP95 call point, it tries to interrupt the normal cycle and get the attention of the main controller. So what it does is it will send out eight pulses, 8 packets of data on each pulse cycle. So even if it's not addressed to this call point, it's going to send a packet to grab the attention of the main controller, the fire panel effectively. But what it can't do is overwrite data from other devices. So there's a frame in the protocol dedicated for devices that are interrupting to place their address to not upset any other device on the network. So the reason why the analog value for the call point will go to 0 is because it's going to be responding on other addresses, and it will overwrite the data coming from other devices on the network, and this will cause corruption and just unwanted effects. So I'm going to remove the glass, and you're going to see the value 16 drop to 0 briefly and then go to 64. There you go, there's the 64, and if I pop it back in, it will just go from 64 to 16. So there you go. If I pop the phone up to, actually you're not going to notice it I don't think, up to the status LEDs of the card, yeah, you don't notice it. Yeah, I'll have to scan addresses with no devices on it. So what I could do is just take these heads off. You'll see the response is less. But when I take this glass out, watch the green LED, its pulse will change. My little explanation on trying to demonstrate the interrupt pulses didn't really work out. As you saw, it was getting, you know, lost in all the noise of the other signals, and you couldn't really tell on camera that there was more pulses there. So what I have done is I've omitted every other device, and the only device on the network is the call point, but the addresses that are being scanned are 1, 2, 4 and 5, so that's just these devices. But these devices are no longer connected anymore, so they're not responding, and the only device connected is the call point, and because it's not getting interrogated, it also is not responding, so the receive is being left empty. So this is scanning 1245, 1245, 1245, and if these were connected, they would be sending their data back and populating these fields. So if I take this out, you will see the green LED flash, and that is the interrupt cycles. So there you go. Let's do it again. Let's get a clearer shot of that because it's out of focus. There we go. And we'll do it once more. So that is the interrupt cycle. Now what I'm going to do is I'm going to spray some smoke into these heads, and we're going to observe the analog value on addresses 1 and 2. Since these are close to one another, when I spray this, it's going to activate both of them. Now there won't be any alarms. These won't activate any alarms because I've not programmed this to handle any inputs from these. All I'm doing is just taking the data from these devices and putting it into an array and then outputting that to the terminal. I will be able to control the sounders, but I'll demonstrate that after I've done the call points. You may notice the analog value for address number 2 is kind of skipping all over the joint. Address number 2 was removed from the system because it was causing false alarms. The same with address number 1. These two devices are defective and I've taken them off, so you will occasionally see the analog value just skipping about, doing like just going up to weird levels, just with clean air running through them. So these are either contaminated or they're faulty. I have no idea, but they're good enough for the test bench, so we'll just stick with them. I'm just going to spray it around about here, and both of them should pick them up like that. And we'll observe the analog value for addresses 1 and 2. And they should creep up. Let's give it more. There we go. The LEDs won't switch on because the LEDs of these devices are controlled not internally, they're controlled by that. So address number 1's hit 127 and so has address number 2. That's the max discrete value that you can get on this, because this system uses a 7-bit. It uses 7 bits for the address, it uses 7 bits for the data packet, the analog value. The newer Soteria ones, I think, use 8 bits for their analog values and addresses, so they can go up to 255 for the addresses and 255 for the analog values. I'm not entirely sure about the Soteria, actually. I haven't got any of the devices to test this out on. If I connect a Soteria device to this with the 7-bit card in the base, if that works, I haven't actually messed with the equipment yet. It should just do exactly this. It should just report back without an issue. I will have to modify my program to do the 8 bits, but that shouldn't be too difficult unless they've radically changed the protocol. But as you can see, the analog value is dropping because I am wafting these things clear. Address number 1 is still sitting at 127. Got to give it time for the internal processor to see it is clear, because I've got little algorithms that run inside the heads themselves and then report it back as the discrete analog value. So there's a bit of pre-processing inside the head itself. There we go. So that is the reason why when you reset the system too early, it will re-trigger, is because these devices hold that analog value above the threshold. So I'm going to turn off active poll. So I'm going to go manual poll, and you'll see the LEDs stop blinking. I'm going to turn the LEDs on for the call point. So I'll go LED 3, which is the command to turn on LED on address number 3. So if I do that, you'll see that blink. That's it sending the data to the call point, and then the LED will switch on. Let's turn the lights down or off. If I go LED 1, I can turn on the LEDs of the smoke detector on address number 1. And if I do LED 2, you know what's going to happen. The middle smoke detector will switch its LEDs on. So if I do LEDs off, I should switch them all off, and there we go. If I do LEDs off again, you will see what happens when it's going to send the command LEDs off, even though the LEDs are already off. So you'll see these LEDs on the Discovery devices flash 3 times, because I've set it to send the command 3 times to each address when I activate it, just to make sure that it's got the message. I'll do that again just for fun. So they're actually flashing 3 times. They're just flashing so fast that the camera can't pick it up. But they are flashing 3 times. You can literally see them shimmer when they're lit. So now let's activate the sounder base. So I'm going to type evac into the terminal and activate that. So there is the sounder base activated. If I type in alert, it will change the tone from evacuate to alert. The beacon base will not flash because I have not programmed it to flash. I couldn't be bothered, to be quite frank. So I'm going to silence that by typing SIL. That should shut it up. Sometimes if you go alert, or not alert, evacuate, and you go silence, you might get a tone hold that some people quite like for some reason. There you go, there's your tone hold. So that's that pretty much. Just this little Apollo test bench that I built using an Arduino, my interface card, and a little breadboard circuit that I just fabricated together in an afternoon. What I'm going to do, right, is I'm going to set the addresses to number 5 so I can turn on the beacon base, because why not, eh? I'll fit it in here. It only takes like a few seconds for it to update. So that's it, compiling. That should update in a minute, and then we'll send that command evacuate. Alert and evacuate do exactly the same thing on the beacon base. It'll just flash the LEDs, so it doesn't really matter. I'll just send either or, and it'll... So there's the serial monitor. It's doing the... When you start this up, I've programmed it to do the auto learn when, or the learn network when you start the Arduino up for the first time. So I'm going to turn lights off and I'm going to type in evacuate, and then we'll point that at that, hit enter, and there she goes. So that's quite bright. So I'm going to turn that off again. So that'll be SIL for silence. And you'll see the little LEDs on there flicker as I send the command to it. And that's it. So that is my Apollo test bench that is driven by Arduino. Hope you enjoyed it. Thanks for watching. a little bit, you know, too long. So if you just gotta let it, see that it's clear again, and then it will calm down again and go back to its resting state, and then that's about the time you reset it. So if you did reset it, you know, when that was still at 127, the alarms would re-trigger